Good evening, student. This is the digital electronics classes. Sixth term, your topics are digital electronics. First, what topics we have in first block means difference amplifier, operational amplifier and its characteristic parameters, operational amplifier and configurations and analysis, measuring instruments. Second block you have measuring instruments. First block you have difference amplifier, operational amplifier, and its characteristic parameters, operational amplifier, configurations and analysis. Second one, measuring instruments, analog measuring instruments, digital measuring instruments. Third one, digital electronics, number systems and logic gates. And fourth, next seventh, third block, sixth one is number systems and logic gates. Seventh one, combinational and sequential logic circuits. And eighth one, fundamentals of microprocessors. And block fourth, modulation and demodulation. In that ninth lesson is amplitude modulation and demodulation. Next one, frequency modulation and demodulation. Next one, elements of superheterodyne receiver. Next 12th one, television transmission and reception. First we will start operational amplifier. In that, what is amplifier? Amplification is the process of conversion of low signal to high signal, which modify the signal from low strength to high strength, either in sound, either in frequency, either in amplitude. It amplify the signal strength. It increases the way of strength of the signals from one region to another region. Here in this lesson, major topics we are involved is difference amplifier, means differentiative amplifier. First, whenever you are studying this lesson, we are completing first one, basic difference amplifier. Second one, characteristics of the difference amplifier. Next, what are the properties involved in the differential amplifier we are studying. Now, first, basic difference amplifier. In that, the basic difference amplifier circuit is shown in figure. Here, what figure we have in that? Once you check it. This is the basic difference amplifier. Is it audible for you? So total nine blocks you have in this lesson, ma. That is first one operational amplifiers. Operational amplifiers. What topics we have in that? First one differential amplifier. In that, what is differential amplifier? What is the characteristics of the differential amplifier? In that basic differential amplifier, basic differential amplifier we want to study it, ma. So the basic difference amplifier circuit is shown in figure. So what is the figure here? Figure I want to show here. So see here, first one transistor one, then transistor two. Transistor one we have the collector current, base current and emitter current. We have the two transistors connecting collector terminal to collector terminal one end, and base terminals to one end. Emitter terminals we are giving input, which is the basic differential amplifier, which is the basic differential amplifier. So in that total, how many blocks? Ma, four blocks, 12 lessons we have. And that first one, differential amplifier. In that, two configurational transistors connecting side by side with uh, collaborative combination is for transistor and of collector terminal and base terminal, ma. So what are the basic blocks involved in the differential amplifier circuit is means it has two identical transistors, T1 and T2, with identical resistors at their collector circuits. The two halves of the circuits are mm, perfectly matched. The emitters connected to minus VEE via the emitter resistor RE properly bias the two transistors. The circuit is energized by the symmetrical power supply minus 15 volts to 0 volts and then 15 volts. The emitter resistor RE is the heart of the differential amplifier, ma. It limits the current available to the two transistors to construct a value of I naught. So that here differential amplifier components, what it is, ma, RE, RC, and IE1 current, IE2, IC1, IC2. So which one is inside, which one is inner side, which one is outer side, we can observe here. And then now try to understand the working of this amplifier. It has two input terminals, ma. One is the output voltage is measured across the two collectors as shown in the figure. Let two voltages of equal magnitude and of the same polarity be applied, one between terminal 1 and the other between the terminal 2 and ground. This causes equal changes in the character currents and the potential difference between the two collectors will be zero. Two collectors will be zero. This means the voltages common to both the terminals do not affect the output voltages. If the base of transistor T1 is driven positive with respect to the base of transistor T2, the base of if the base of transistor T1 is driven positive with respect to the base of transistor T2, the current through transistor T1 increases and the current through the transistor T2 decreases. Now, characteristics of the differential amplifier. So up to this, what we are studying, how it is constructing, how to take the output, how we are giving input, were shown in the diagrams. Now, characteristics of the transistor. So here, what it is, characteristics. Characteristics of the differential amplifier. So here what it is, gain figure represents a differential amplifier with two input signals V1 and V2 and one output V0. Each of these voltages is measured with respect to the ground. Under ideal conditions, the output voltage V0 is given by V0 is equal to AD into V1 minus V2. So, what is that, ma'am? Well, output voltage V0 is equal to AD into V1 minus V2. What is AD here? The gain of the amplifier for the different signal. What is AD here? It is the gain of the amplifier for the different signal. It is called the differential amplifier gain. If V1 is equal to V2, the output is 0. If V1 is equal to V2, the output is so here see how it is, the in the V naught is equal to AD into V1 minus V2 plus AC VC. VD is equal to what it is, V naught is equal to AD into V1 minus V2 plus AC into V1 plus V2 by 2 into AC VC, where AC is the gain of the amplifier for the common mode signal for an ideal difference amplifier. AC is equal to 0. The ratio of the differential and common mode gains AD by AC indicates the effectiveness with which the amplifier rejects the voltage common to both the input signals. It is termed as the common mode rejection ratio, CMMR. Then CMMR is equal to what it is, AD by AC into rho. AD by AC into rho. For a good differential amplifier, CMMR dB 20 log 10 of AD by AC is nearly equal to 80 to 120 dB. Therefore, combining operation 1, 2 are CMR ratio, what it is, AD by AC into rho. What is AD? What is AC? Already we know that. Now voltage, operational voltage V naught AD VD into 1 plus 1 by CMMR VC by VD. Therefore, a rigorous analysis of the circuit which is behind scope of this book yields that AD by A is minus HFE into RE by HIE. An examination of the An examination of the above equation shows that the differential amplifier should be designed to have a high value for CMMR. High values of CMR are achieved by choosing transistors having large values for HRC, HFE, and allow values of HRE along RE. Worked example, a differential amplifier has the following parameters. What are they? Gain వచ్చేసి 10,000 AD differential amplifier. V1 is 6 millivolts and V2 is 4 millivolts. CMRR is equal to 10,000. Then what it is, ma, calculate the output voltage. What is the error introduced in the output voltage due to finite value of CMRR? Ideal conditions, AC is equal to 0, CMRR is equal to alpha, V naught is equal to 10,000, 6 millivolts to 4 millivolts. Then 10,000 into 2 into 10 power minus 3, that becomes 20 volts. Ma, 10 power minus 3, 10 power 4. Then 10 power minus 3 cancel. 2 into 10 means 20 volts. Then practical amplifier is V naught is equal to AD into V1 minus V2. So this is the picture, ma. Now what we have checked our lesson. So in summary, what we are studying in this lesson, differential amplifier has two inputs and one output terminals. Most important characteristics of the difference amplifier are the differential gain and CMRR. Differential gain and CMRR. Amplifier has two input terminals. The output voltage is measured across the two collectors. Output voltage is measured across the two collectors. The differential amplifier. The difference amplifier may also be measured in a single-ended output model. Now, draw the circuit diagram of the differential amplifier and explain its action in first question. Second one can give an expression for the gain of the differential amplifier. Next, what is meant by common mode signal? So, define common mode rejection ratio CMRR for a differential amplifier. And what should be the magnitude of CMRR for a good differential amplifier? Next one, common mode rejection ratio means the ratio of the differential and common mode gain indicates the differences effectiveness with which the amplifier reject the voltage common to both the input signals. Further reading in this lesson, we are studying about the basic circuits, electronic circuits, integrated circuits, basic electronics, electronic principles, electronic circuits, linear integrated circuits, etc. Now, second one, operational amplifier and its characteristics parameters. Operational amplifier and its characteristics parameters. In that, what it is, objective introduction, characteristics of ideal amplifier. So up to this differential amplifier is over. Next operational amplifier, block 1 differential amplifiers figure and CMRR ratio, that all covered in first block. Second block we have operational amplifier and its characteristics parameters. Characteristics of ideal operational amplifier, block diagram. Next one, feedback arrangements. Next one, operational amplifier parameters. Characteristics of amplifier, what we have, open loop gain, A naught is equal to infinity, CMRR infinity. Next one, input impedance, Z1 is equal to infinity. Output impedance, Z naught is equal to 0. Bandwidth, beta is equal to infinity. Next, stability S is equal to infinity. Slew rate, we have infinity, and offset voltage and offset current 0. Next, see operational and digital electronics equivalent circuit and block diagram of ideal op amp. Ideal op amp, see how it is. V plus, V minus, output impedance, Z naught. Operational amplifier block diagram.